So in this problem, we need to determine the equation of a parabola with focus at 3, 0 and the directrix with the equation 3x plus 4y minus 1 equals to 0. Let's try to understand the problem graphically first. So here we will consider a straight line with the equation 3x plus 4y minus 1 equals to 0. So we're going to consider this to be the equation of the directrix. Now we're going to draw another line which is going to be perpendicular to this directrix line, and this line is also referred to as the axis of symmetry line. Now on this axis of symmetry line, we're going to consider a point F having the coordinates 3, 0, and it's referred to as the focus of the parabola. Now in order to find out the equation of the parabola, we're going to consider a point P and its coordinates, let's say h, k. This is going to be the locus of the parabola P, and using this point P we can find out the equation of the parabola. All you have to do is join point P and point F, and then we're going to drop a perpendicular from point P on the directrix lines meeting it at M. Now by the definition of a parabola, we know that the length of PF will be exactly equals to the length of PM. Now here we can easily find out the length of PF because all we have to do is use the distance formula here. So we'll take the square root underneath the square root. First we'll take the difference of the x coordinate. So we do h minus 3. And then we're going to square this result. And next we're going to add it to the difference of the y coordinates. So that's k minus 0. We're going to square this value as well. Now next this will be equals to PM. Now PM is the perpendicular distance of the point P from the directrix lines. Now how do we obtain this particular length PM? So let's say we have a point P with the coordinates x1, y1, and then we have a straight line with the equation ax plus by plus c equals to 0. Here the point P, if we drop a perpendicular from P on the line such that it meets the line at point M, then this perpendicular distance PM can be obtained by using the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So we're going to use this particular formula here. So here we have to take the absolute value. So we'll start with the coefficient of x, so that's 3. So 3 gets multiplied to the x coordinate of the point P, so that's h. Next we're going to consider the coefficient of y, so that's 4. 4 will get multiplied to the y coordinate of point P, so that's k. And then we have the constant term, that's going to be negative 1. This is going to be divided by the square root of 3 squared plus 4 squared. Now we're going to simplify this. So what we'll do, we'll square both sides. Squaring both sides gives us h minus 3 whole squared plus k squared will be equals to 3h plus 4k minus 1 whole squared divided by 25. Now we cross multiply and simplify the term, so that's going to give us 16h squared plus 9k squared minus 144h plus 8k minus 24 times hk plus 224 equals to 0. Now what we'll do, to find out the equation of the parabola, we'll have to replace the value of h with x and the value of k with y. That was going to give us the equation of the parabola. So we finally get 16x squared plus 9y squared minus 144x plus 8y minus 24xy plus 224 equals to 0. So this is going to be the required equation of the parabola with focus at 3, 0 and the directrix equation given by 3x plus 4y minus 1 equals to 0.